A very happy evening, everyone. I, Khushi Jiravla, currently pursuing my master's in physics, shall be the host for the evening. I want to express my sincere gratitude and want to welcome everyone who were with us and also those who have joined us today. Before getting further, I am much obliged to appreciate our sponsors, Genex Space, Samarth Academy, and D Space, without which our event wouldn't be a great success. One of my favorite sayings goes like that one small step for a man is one giant leap for mankind. Those leaps of mankind to travel through space and ravel the mystery were made many times. These space voyager include stories from the first dog into the space, Yuri Gagarin, the first man into the space, and to the greatest day in mankind, landing on the Earth on the moon for the first time on July 19th, 1969. Yuri Gagarin experienced the beauty of space and he said, "When I orbited the Earth in spaceship, I saw for the first time how beautiful our planet is. Mankind, let us preserve and increase the beauty and not destroy it." And till now, plenty of space companies planning space travel, colonisms on many planets other than Earth. Space, the mysterious place. Over the decades, rockets have been the one-stop solution to accessing it. And as we move ahead in time, we'll continue to aid our dreams and exploration. As Stephen Hawking says, I don't think the human race will survive the next 1,000 years unless we spread into space. There are too many accidents that can befall life on a single planet, but I am optimist. We shall reach out to the stars. The first rocket was sent after several attempts. And this, as a proud Indian, I cannot forget the day when Kalpana Chawla's return, when the whole world was waiting for the return of seven space members and the space shuttle Columbia flight STS 107. But due to some technical issues, it disintegrated over Texas during its re-entry into a Earth atmosphere, and that disaster killed seven of our astronauts. But however, there were many such befalls, but I am sure to get over mankind to greater heights. Us humans will not fear this and not stop. We will reach the greater heights. To talk more on this topic, I would like to call and introduce our speaker for the day, Ms. Dipti Ramesh, a SSERD trainer. Dipti has completed Electrical and Electronics Engineer from Rajarajeshwari College of Engineering, Bangalore. Space has fascinated her since the age of 3 with its infinite frontiers and unexplored cosmos. Astrophotography and sky watching being her greatest passion, with dancing and painting being her hobbies. On a lighter note, to you can say, she walk, talk, eat, sleep aeronautics.
Thank you so much, Khushi. That was a wonderful introduction. Thank you so much. Hello, everyone. A very good evening and good morning to international people. I am Deepthi Ramesh. I'm basically a space enthusiast and I'm part of SSERD. So, as when it comes to journey to space, I'm more fascinated with rockets, especially my inspiration, the missile man of India, Dr. APJ Abdul Kalam, Kalpana Chawla, and Sunita Williams. It has been my dream to go into space, and you can call me an astronaut aspirant. So today we are going to have a session, a short course on journey to space. Okay, first, what comes to our mind? Like all our minds, journey to space. It's just rockets, astronauts, the training, spacesuits, the infinite cosmos. But the major challenge lies in reaching that cosmos, escaping the gravity of the Earth. So today, we are going to learn about the journey to space and beyond. So, The first thing, how does a rocket move? Can you all see this? I hope you all can see this video. We can see that these people are having a fire extinguisher and they're using this force which is exerted from the nozzle of these fire extinguishers, which are pushing them, and even the person is going around. So this is the same concept we will see in the rocket propulsion. Now, let us see the past, present, and future of rockets. You all know that there have been many stories and many inventors behind many things like light bulbs, telephones, etc. But here we want to see the past, present, and future of the rockets. Because the first thing is we want to know who came up with the first rocket. Okay, but that is something which goes way beyond like 10 centuries. Like in 17th century itself, we had people who just like they used to burn these rockets as a small celebration, like how we prepare in Deepavali, or we burn firecrackers in New Year. So now let us see who are the actual fathers of the modern rockets. Okay, before we go. So first of all, the beauty of this is there are fathers of rockets and not father of a rocket, because there are three people who at a time came up with this concept of launching a rocket to space and exploring the cosmos, especially looking back towards earth. So those three were from Germany, an American, and a Russian. So from Germany, we have Hermann Orbit, and from Russia, we have Konstantin Tsiolsky. From America, it's Robert Goddard. We all are aware of Robert Goddard and Hermann Orbit. Now, the person you see in this picture is Konstantin Tsiolsky, and here is Goddard, sir. And here we have both of them with their models of rockets. The beauty here is you can see that there is a similarity in both the cases, both the pictures. But the beauty is they never copied each other's work. Like they came up with this design on their own. It was absolutely on their own which they came up with this design. This is the first design of a rocket which can be launched into space. Okay, this is Hermann Orbit. He and his team came up with lots of model rockets, and they also launched missiles basically. So this is one of the pictures of Hermann Orbit, which is with his team. So this is one of the other picture which is really enthusiastic, because you can see that the height of this rocket is more than a human. So which is really really a big thing. Now we have all the three members who we have all the three members who are the fathers of rocket. It's rocket science doesn't have one, but it has three fathers. Okay. So now let us go to the past. We all know that we got these firecrackers and everything from China. So what happened in way back in 15th or 17th centuries? These Chinese people, they just put some gunpowder inside a bamboo stick, which you can see on the picture like this, and they used to throw it into the fire in case of any celebrations or anything. One time it so happened that there was a hole inside this bamboo stick through which this gunpowder came out, and suddenly it just got launched into sky. From then they got this idea of launching these rockets, firecrackers, in the war. Basically all these firecrackers were used in the war first. Rockets were all used in the war. So what they did, they just tied those bamboo sticks to their arrows and started firing at the enemy. So this is how the idea of rockets came into the mind of people. So now, coming back to India, being a proud Indian, I would really love to tell this story. This is from Tipu Sultan's time. Uh, as you all know that Tipu Sultan was a wonderful warrior. Okay, he what he did was he just replaced these rockets and its stand with iron stands, if not bamboos, because that gave him more sturdiness, so that when the rocket is launched it gave them a sturdiness so that it can go to a higher speed. Okay, he also increased the height of the stand as well, the launch pad as well. Now we can see that there are lots of Britishers in this picture. It so happened that as everyone knows, India got invaded, and we have the pictures from these Britishers in and not Indian, so Tipu Sultans. Okay, this is how it came to India. Now, the next thing was intercontinental ballistic missile (ICBMs). These were the first model rockets, or you can say missiles, used for wars, because all these are very small ones which can be like launched into the enemy continent. Like it is not something, it can travel kilometers together. It's not something where you have very minimal distance. So it is, as the name says, it's intercontinental ballistic missile. It was used in wars. So this is one of the pictures of an intercontinental ballistic missile, that is an ICBM. This is how the ICBM were carried to the war fronts. It is really heavy. You can just see the size of a human in comparison with an ICBM. So this is how rockets came into existence. Next, here are some pictures of ICBMs from different countries. This is from America. Okay, we also have ICBM from Russia. You can see that it is almost similar to the Soyuz rockets. They have the similar design. Soyuz has still maintained the similar design. This is one of the ICBM R7 Semyorka. This is a Russian ICBM. This is not a rocket. This is an ICBMs. So later, then we have Mercury, that is Atlas 6, the Mercury Vision Atlas 6. This is from America. Then we have Atlas Agena rockets. These are the rockets which are of the class Atlas, and the names are Agenas. These are all ICBMs and not rockets. Now we have the biggest man-made rocket, that is the Saturn V, which was used for Apollo missions to launch humans into space. Actually, previously these rockets were used to wage war against people and with other enemy countries, but later people started thinking that they can take it to space as well. So as you all know, in the previous slides we got to know that the fathers of the rockets, they all came up with an idea to explore the cosmos, which is beyond. Okay, so they started modifying these ICBMs. Like, we didn't build the rocket directly, but we started upgrading the ICBMs. Basically, you can call it a upgrade or a modification. So what they did was, consider this to be an ICBM. What they did was, they just modified the payload, the top, the nose cone of it, and just fitted that with a payload, be it a satellite or humans. So this is how ICBMs were modified. So this is a Saturn V rocket, and you can see the comparison of its height. The height is really 363 feet, and in compared to the Statue of Liberty, it's really big. Statue of Liberty is just 305 feet, and the building structures are nothing in comparison with the rockets. So this is how the rockets came into existence. Now we have rocket propellants. We saw that these rockets can be modified and sent to space. Now, how are we going to send it to space? Because gravity is a major issue, which has been a major challenge, basically a major challenge for us to escape from. So what we need is a propellant. Actually, it's not called rocket fuels, it is rocket propellants, because they help in propelling the rocket to space. So this is rocket propellants. A rocket propellant is basically a chemical mixture. Okay, it is burned to produce a thrust in rockets. Basically, it provides the thrust inside this rocket, and it consists of fuel and an oxidizer. What happens, this fuel, when it burns, is combined with an oxygen. It needs oxygen to burn. Basically, it needs oxygen to burn, and that produces a gas for propulsion, which provides an opposite thrust. As you all know and aware of the Newton's third law, every action has an equal and opposite reaction. The same law helps us to propel the rockets into space. So basically, everyone will be having an idea about fuel. But what is an oxidizer? That is an agent which releases oxygen for the combination with the fuel, because you need the fuel to burn. Okay, so you need oxygen for this rocket to propel into space. So have you all, you all must have seen that when there is a countdown, you can see that lots of in last 3 seconds you have a burn. burn up, ignition, basically ignition. So that is because the oxidizer and fuel are being released together so that they propel the rocket to space. So now let us come to the launch vehicles. So which are the launch vehicles which we normally use? Okay, these are one of the famous launch vehicles. Now we don't have ICBMs. We do. Matlab, it's in museums right now, but now we have big rockets, huge rockets, which we have launched or are launching our astronauts into space. And it's not only for humans and astronauts to launch into space, it's also for satellites and even certain experiments like sounding rockets, which goes to ionosphere to study that part of the earth, that layer of the earth. So we have ICBMs. They are the first launch vehicles, as you all know. So this is Titan 1, Peacekeeper, and Minuteman 1. All these were modified so that they can be launched into space and they can be deployed with satellites, or they can study the Earth's upper atmosphere, which is not reachable from human. So yeah. So this is one of those major rockets and one of my personal favorites. This is Falcon Heavy by SpaceX. This is currently the world's most heaviest rocket. It is really a very heavy rocket which can go really which can take us to Mars. Yes, which can take us to Mars. So we have rocket boosters. If you all can see my video, yeah. So here we have rocket boosters. The parts which you can see, the small particles, like small rockets which are attached to the main body of this rocket, are called boosters. So these help in propelling a heavy rocket to the space because you need more fuel. So that's how we propel into space. And if you can see the space shuttle, the model of this is a model of a space shuttle. So it has boosters. These two are the boosters which propel the rocket up to a certain height because you need to escape the gravitational force from the earth, and you need enough thrust to do that. So yes, boosters are the major requirements. Then this is one of the pictures from Falcon Heavy launch. This is how it was brought to the launch pad. This is one of my favorite moments because it just stood majestically and ready to go, just go and explore space. These are the main engines. These are the engines installed in this, sorry, heavy Falcon Heavy rockets. So you can see that each part, even the boosters and the main engine, sorry, main body of the rockets have 9 engines together. So all these are liquid propellant engines and they're not solids. So this is an image of CEOs, which is one of the famous rockets, which is like now we have SpaceX, but when there was no SpaceX and space shuttle was stopped for a brief moment, so we had CEOs. It it can take astronauts to International Space Station and beyond. CEOs has always been a lifesaver for everyone. As we all know, there was a Cold War going on between Russia and America. Like everyone wanted, there was a space race, like who is going to go first. Russia launched its first satellite Sputnik 1, and USA launched its first satellite Explorer 1. So that's how we got this CEOs. Then later they all just clubbed together and they started exploring the space together because it's easier for any task to be done in a team rather than being in competition with each other. Because it's space is a very vast thing, and even if every one of us go and help each other in exploring space is not enough. So yeah, this is one of the rockets which is used by Russia. It's called Soyuz. Now, this is how a Soyuz looks on the launch pad. It is really big and is used. It's a reusable rockets. These are reusable rockets, and these can be launched. And these were used. These were used to launch astronauts. Now we have rockets made in India. This is one of my most secured or one of my most favorite parts. We have SLV and ASLV. Now we don't use it, but we have PSLV, GSLV Mark II, and GSLV Mark III. As all of you are well aware, PSLV was used to launch Mangalyaan to Mars. Yes, it's a very small rocket, but It helped us to reach Mars and explore Mars, create a history. Now, GSLV Mark 2 and 3 are very famous for the missions, Chandrayaan missions. So, we have Chandrayaan 1 and Chandrayaan 2. So, these are the rockets which are currently in use, and India is still using it. Now, we have the next version of rockets, those are space shuttles. I hope every one of you are aware of our very own Kalpana Chawla. So, Kalpana Chawla and Sunita Williams both they traveled to space in these space shuttles, one in Columbia and one in Atlantis. Okay, so these space shuttles they have two boosters and a fuel tank, a huge fuel tank with the space shuttle attached to it. So after some time, after once it has reached a certain amount of time, these boosters are going to get separated, and this space shuttle is going to propel forward. And after reaching a certain height, a parking orbit, even this fuel tank is going to separate and come down on Earth. For this, let me share a simulation. So here is a simulation. So this is the underneath of a launch pad. This is the underneath of a launch pad. So this is how a launch pad looks. This is how basically a launch pad looks. This is Atlantis. So we are almost ready for the launch. This is a simulation. So yeah. Like many of you would have had this question, like why isn't space shuttle used now? The thing is, space shuttle uses solid rocket fuel. It's compared to we now use liquid propellants, which is more safer, even cryogenic propellants and liquid propellants, which are really safe compared to this solid fuel propellants. Because if you guys are aware, it is the Challenger, which was taking 7 astronauts, it just exploded after the 75 seconds of its launch, so which was proved unsafe. The solid rocket fuels are really unsafe compared to the liquid, but it's not like we can't use it, but we can. It is more safer to use the liquid propellants than the solid ones. Now we are just waiting for the launch sequence to be initiated. So this is a basic simulation. Like if you want to do it, this is the nearest this one. Now we have a rocket launch. Now we have ignition and a lift off. As it is going towards the space station, International Space Station, and it also need to follow the azimuth angles. So this is very important. The space shuttle launch stacks then starts to pitch over backwards. Okay, so this is how it propels. You can see that even the engines of space shuttles are also on, but the major ones are these boosters which are taking the Atlantis, the space shuttle, into space, near to the International
Dipti,
Space Station. Yeah.
Dipti, it is not visible actually.
Oh, just a minute. Okay, is it visible now? Okay. Now, yeah, I hope it is visible now. The screen is visible now. We have this space shuttle ready for the launch in Kennedy
It's
Space
still
Center.
black. It's still blank.
It's still blank. Is it visible now?
No. Yeah, it is. It is.
Is it
Just go full screen.
now?
Oh, no. It isn't showing in the full screen. Do not.
Oh. No, it's in full screen basically on my.
No, no, it's not visible in the full screen. You can show in without full screen. It is visible when it is not full screen.
Okay, how about now? Is it visible now?
No,
Yeah, I'll just share it again. I hope it shares. I'm so sorry for this technical snag. Okay, is it sharing now?
yes, it is.
Okay. I hope everyone can see this. Okay. So here we have the launch sequence. We are just waiting for the rocket launch. This is space shuttle and like ready for the launch in Kennedy Space Center. Yep. This is the close view of the same. Now we have the main engine ignition and the solid rocket booster ignition, and we have a lift off. This is how basically a space shuttle takes off or launches off. It needs to orient itself in such a way that it can escape the gravitational force of the earth and also maintain a proper azimuth angle. If not, it's going to like fall down back to earth because of gravity. So now we have space shuttle, which is being launched. Atlantis being launched to the space. So it allows, it just puts the astronauts in the same orbit which we use right now. Now we use Falcon rockets, Falcon 9 and Falcon Heavy. We also have Blue Origin. So it's just going to deploy astronauts into space. And once that is done, the Dragon module is going to go and attach to the International Space Station. That we use that now, but in previous when we were using space shuttles, the space shuttle used to go and dock in the International Space Station. So, yeah, here we have the other other angle of the space shuttle, which is very important because it goes in the curved path, a parabolic path. So we all can just lean back and enjoy this simulation now. These are the major controls which we will be seeing in the control room. So, yeah. I'm really quite excited, even though we have such advanced technological rockets. But space shuttle have always been one of my most favorites because when I was learning about rockets, these were in town, like they were like Falcon 9, how we have now. So yeah, we should be having the separation any moment, the booster separation. So now we are almost reaching. Yeah, we have the booster separation. So we have this booster separation, and this is how it separates. But still, the main tank is attached to the space shuttle. Okay. Now, even they have to like it has to separate. The space shuttle has to separate from the main tank. So normally it was like those boosters are going to fall back to the oceans. The boosters are never programmed to fall back to the surface of the earth, but they are supposed to fall back to the oceans. Have you all, if you all have seen, like we have videos where even the dragon's falcon is going to come back and land, and even the dragon module is going to come back and splash down on the on the water, because it is much safer on the water where we can get back those boosters. But if it falls on the surface, the solid rocky surface of the earth, is going to just disintegrate, and we can't reuse the vehicles. These are basically reusable spacecrafts and reusable rockets, which really helps us to have a proper economic control, because every time building a rocket and building a space shuttle is and launching them is really costly. It is really costly. If we have reusable vehicles, then it is quite easier for us to launch rockets, launch astronauts, and launch these satellites into space. So we should be having the major fuel tank separation any moment now. So the main engine is cut off. Now we have the main engine cut off. And this is a simulation of how uh, Earth looks from space. This is really mesmerizing. See, we have the main engine separation, the main fuel tank separation. Now the space shuttle is on its own and in its path towards the International Space Station. Yep.
Guys, due to some network issues, Dipti will be joining us in a minute. I hope everybody waits a little more. She'll be there in a minute.
Oh, I'm so sorry. Yep. So I'll just share my screen. So is my screen visible, Kushi? Hello?
Yes, Dipti, it is visible.
Yes. So we saw the launch of space shuttle, and now we are going to see what is it to be in space, create building a home in space. So this is our International Space Station. This is our International Space Station. Like we have multiple countries helping us in this. We have America, we have Russia, Canada, Europe, Japan, etc. So it's not one man. One man. It's every country. Like it's from the Earth, we can just call it from the Earth. Now let us see the morning routine of our astronauts. Once they are like docked into space station, International Space Station, they just brush, they start showering, and the essentials are really a challenge task in space because we have microgravity, and everything doesn't happen like how we have gravity. So these astronauts, they use these ingestible toothpaste which they can swallow after they have brushed, and they use a rinseless shampoo. You need not rinse it, you can just wet your hairs, use the shampoo, just clean your stuff, I mean clean your hairs up, and take a towel and wash it off. You need not have a rinse. So, and we also have a washroom facility there, but that's quite challenging. So now what are the foods which are eaten in our International Space Station which are available? We have three types of foods, that is natural form, rehydratable, and thermostabilized. So in the natural form of food, it does not need to be processed like green apples. So these are not processed, they can be taken but have to be consumed within 1 or 2 days once they have received them. Then we have rehydratable foods. These foods, we just extract the water from them, they are dehydrated and packed in a vacuum sealed bag. The astronauts there need to rehydrate it. We have water facility in the International Space Station, and they have to rehydrate it, heat it up, and just directly consume it. Then we have thermostabilized. These are the foods which are heated to a certain extent where it is enough to kill the bacteria present in it. So these are probably, they are packed in cans, they are packed in cups and pouches. Now, the next is the exercise. Why is exercise really a major part in International Space Station? Because of microgravity. When you go to space, you have a sudden change from blood pulling down to your feet because of gravity, and the blood just coming back to your head, like how you squeeze a balloon. So it just all the water flows to your head. It's like like you will become bloated. Your head will become where you feel like you are sick. you feel like vomiting. So you need to maintain your health at that time. You need to help your muscles, and like it will take some time for everyone to get adjusted to this, but you need to exercise so that the blood flows to your leg and you don't feel unhealthy in the International Space Station. So these are few exercising machines which are in International Space Station. And this is basically the research lab. This is where the astronauts conduct experiments. You can see there are lots and lots of electronic devices all around them, like nerves in human body. So these are the equipments, and these can be the basically you have everything there. You have laptop, you have all the biological needs, you have all the technical needs and everything. So this is how a food is consumed. You just If you just squeeze a water in International Space Station or in space, it will just become a bubble because of the surface tension exerted. So yeah, astronauts conduct a lot of experiments on these and just check how can we survive in the space, in the space vacuum or in the microgravity for a longer duration, because having a microgravity is very harmful to human body if you stay for a very long time. We have astronauts who have stayed there for a longer duration in a longer space missions, like 1 year or just 1.5 years or 6 months, but that is also quite unhealthy to the body. So they are just conducting experiments as to how we can survive in microgravity for a longer period of time. Now, everyone would have been having this question in your minds, like, do they have internet in space? Yes, they do, but they have their own separate bandwidth of internet. They can watch all the live sessions happening like football, and they can even contact their people and speak with them. So yes, they do have internet and they do have recreation time. So now, how are we going to sleep? Sleeping is a major challenge because you don't have gravity. Now, what we do, they just have a bag, a sleeping bag. They just put themselves into it and strap it to the wall of International Space Station so that when they're sleeping, they don't float away. So, in your left, you can see an image where an astronaut is sleeping. It doesn't really matter if you're upside down or if you're like standing, or you can even sleep while standing there, because it doesn't really matter. You're basically floating. So, in past, we had bags, sleeping bags. Now there have been small rooms in the International Space Station where you have your own space. After like work, you need to go and speak with your near and dear ones, you can do that. So now, how are we? Is space only limited to International Space Station? No. Humans want to go back to moon, and we have a program initiated. It's Artemis. They're targeting 2024 and to land the first women on the moon back. The Artemis is a program which is going to take the humans back to the moon. And we also have the Starship from SpaceX, which is targeting Mars, who wants to build a settlement in Mars, a human settlement. Both Artemis and Starship, they're targeting human settlement in space. Now, do I need to become like, do everyone want to become astronauts? No, some of them wants to become something else but still go to space. So for them we have the space tourism. This is by Blue Origin and Virgin Galactic. You can see that we had a space flight, both Virgin Galactic and in Blue Origin. This is an astronaut who is like experiencing and enjoying a space tourism. You just need not be an astronaut, you just need to take some training and you can just visit space, enjoy the beauty of the earth, and around it you can even see many things. You can see moon in a very near distance if you're lucky, if you're going in that time. So yes, we have space tourism for people who want to pay and who want to make a visit. So this is Sirisha Bandla, the second woman to go into space, the second Indian origin woman to go into space, and one of the inspirational women we have in the world. So, okay, now what is the amount we need to pay if you want to become space tourists? So it is not much. It is just $450,000 per seat. Just somewhere it comes around 3,000. I mean, sorry, 3 crores in Indian currency. That's it. If you pay that much, you can have a space tourism. So that was it. This was the journey to space, and thank you all. Now we are open to questions, and you can just shoot your questions to me.
This journey to space has given me some profound insights and a mixture of intangible emotions of excitement, wonder, and made me speechless. Thank you, Dipti, for your amazing words. And I request Kushi to take forward for the question and answer session.
Thank you, Dipti, for wonderful talk. There were many questions in the group, so I would like to take few of them. So
Yes.
first one is many rocket launches have failures and results in huge losses. What are the ways to avoid it?
The reason means is to just carry out your research, because when you're having your experience, it's a very wonderful question because it's a matter of economy. The thing is, you have to keep on doing things, try again. And because it's a very huge, it has a very huge economic background. The only thing we can do is we can just keep on experimenting and limit the number of disaster which can happen, which for example, the Falcon 9, it had so many failures, but they learned from their failures, and they made sure that their rockets can launch and put the Dragon into orbit, come back safely and land back so that it can be used. The only thing is keep trying and learn from your failures.
Thank you, Dipti. The other question is why space shuttle was retired, wherein the scientists were able to upgrade it in the case of any problems. Like they're talking about Hubble Space Telescope, which has been retired recently, right? So
Yeah.
why it was retired?
Okay, so Hubble, it was already 20 years since it had been launched, and we have one more telescope, the huge telescope James Webb, which is being launched in this, which is due for the launch in this December. Because now the thing is, every thing in space or in this world has its own lifespan. Okay, Hubble really crossed its expected lifetime. Basically, it served human more than it had to. So, and all those parts, the parts of Hubble, the small parts, were failing, and it was really not cost effective. It was really costly for us to go there and repair it every time. So yes, at some point of time, Hubble had to be stopped, and we are launching James Webb Telescope. It's like welcoming new and thanking the old.
Uh,
Th- thank
Thank
you,
you,
Dipti,
Dipti.
for answering. Thank you, Dipti, for answering the questions and students for asking them. Had a nice time with you. It's time
Thank
to
you.
conclude the session. Let's meet tomorrow with another energetic speakers, expert academician Sneha Hublikar and Nikita Ma'am, co-founder of SSERD and CEO at SSERD, ambassador for studies in France, Kalpana Chawla scholar ISU. Let's meet tomorrow.
I also want to thank our sponsors. Mrinal, can you share the screen? I want to take our time to thank our sponsors, Samarth Academy. Samarth Academy is one of the fastest growing edutech companies in India. With more than 20 plus years of experience in this field, Samarth boasts of a strong presence, especially in Bangalore, the IT capital of India, under the visionary leadership of Mrs. Sneha Hubbalikar and expert academician Summer caters to the academic and extra coaching needs for kids from class 1 to class 12 across all leading boards of India. Samath focuses on coaching and guiding the young minds mentored ably by the best teaching faculty who guide students to excel and break away from the normal stereotypical route approach to studying. We give utmost importance to facilitate hassle-free learning, regular worksheets, periodic assessments to work learning easy and effortlessly for students. Yeah, interested students can uh, watch out for Samarth successful experience and join Samarth Academy. I also want to also want to express my gratitude towards this space which is an ISRO official merchandise store. To order your set of cool ISRO merchandises, visit thespace.com. Lastly but not least, Genex Space is an edtech company dedicated to creating and providing high quality all around space education and services for students and institutions. Formed with the key takeaways of SSERD, a space education and outreach NGO, Genex Space is committed to igniting curiosity and preparing the young generation for the space age to solve significant challenges of our time with the help of space science and technology. We aim to educate and guide curious young minds to achieve their space dreams with the space institution organizations, companies, startups, and professionals. Last but not least, I want to thank everyone present here who made this event a great success. Thank you.
I and Kushi are signing off. Still then, educate, inspire, and innovate. See you tomorrow. Bye.